This
Visit.
conference will now be recorded.
It's been a while since we visited on ownership transfer, and I wanted to just give a bit of an update. Uh, Last time we talked about this, um, we settled on basically. Let me recap where we landed. So there was three flavors of ownership transfer we described, characterized. There's authenticated ownership transfer, where you're sending signed commands to the device. Physical presence ownership transfer, where you just assert ownership, or sorry, assert that you are physically at the device, and then that's a signal to the device that it should allow you to take ownership. And then we described volatile ownership authorization, which is a flow where a device can take receive a key at, say, t equals 0, latch it into the device's memory in a volatile manner, and then enforce policies based on that key going forward until the next reset. So this is essentially, like, to kind of describe this, it's like a temporal privilege reduction. Like, whoever can get that key into the device first wins, and then from thenceforth that key is the law of the land, and you can now expose that device to less trusted entities. So we talked at length about the challenges involved in authenticated ownership transfer, where if you don't have strong controls over your devices as they transit through the supply chain, like as they enter or exit a data center environment, then that leads to some very painful coordination problems where the owners have to cooperate with each other. Everyone who might end up owning a device um, essentially needs to talk to a shared database to exchange unlocked tokens. This would be a challenging endeavor to get right across all of the different places where a device might land after it's been owned by somebody. And this is why we thought, hey, maybe the combination of volatile ownership authorization and physical presence ownership transfer might do the ticket, do the trick. Uh, in the intervening time between when we last met on this topic and now, I've been doing some research and talking to various folks within Google and outside, and I'm questioning whether that is the right direction, whether there are use cases which require authenticated ownership transfer. So this is like, I'm looking for feedback from the community. Um, I have some more slides to go over, like some more thoughts on this. Um, but it's possible that authenticated ownership transfer may need to end up being defined, in which case we'll just need very tight guidelines on how it's used. Um, so let's um, and feel free if someone has thoughts, feel free to interrupt or chime in. So yeah, so there's some problems, right? So we talked about authenticated ownership transfer requires these tight control of these devices, and if you don't have that tight control, you've got to have this coordination.
So Jeff, sorry, I was trying to get
Sure.
off mute. This is Eric. So I thought the authenticated transfer was really the key use case for that was like denial service, someone coming in and taking a device and then denying that in some type of. So if we remove this, how do you prevent, someone from taking or an entity from taking ownership of a device?
Yeah, that's I think that's where it kind of lands, is one of the key things that uh, well, if you were to have the thinking there would be like, if you were to have, say, like physical presence ownership transfer, then you could,
Right.
yourself that,
Agreed.
someone with physical presence can do many dangerous and deadly things to your devices. So taking ownership maybe is not the chief thing they would try to do if they're trying to deny you service.
So, but I agree with that, Jeff. But I wonder about another case that where I think authenticated ownership transfer is really important is in the supply chain,
Mm-hmm.
right? When you may have a bunch of steps, right, in between the time you create a device till the time that device is part of a platform and ends up at some data center somewhere, right? And maybe there are certain things that you need to do to that device in the supply chain that the different contract manufacturers or whoever need to do, right? These are
Yes.
cases where you want to lock the device, right? And then keep it in that state until it gets to the next place, so things cannot be interfered with.
Completely agree. Like I think a lot of the discussion on this topic from my side has been more like focused on what does it look like once the device arrives in a data center. But it's a very valuable like perspective to make sure we cover what it looks like before devices arrive. So yes, and
So
I think
Alberto, are you thinking that, like, as an example, if we manufacture a device and that device goes to a board manufacturer, we would transfer ownership to that board manufacturer and then transfer ownership to the integrator and then to the final, or to some number of steps, and each one of those steps would effectively be a transfer ownership? Is that the thought process?
Yes, that's what I was thinking, especially if, and the point of doing that would be that that device manufacturer needs to do some setting of something in that device, right? Or each one of the steps needs to
I
do
think
some setting.
it's a very interesting perspective. So I just want to make sure that I followed it,
Right.
because there
Yeah,
is
that
stuff,
was it.
right?
Yep.
Because we have steps where, like the diagnostic firmware or anything that's on the board line, we go through a specific step to invalidate that when we move it to production. So, but there could be end steps in the production process. So having a way to do that in a standard way, I think, would be a good thing.
Right. Right.
Mhm. Yeah. No, I just talked a few minutes ago about like if your threat model is an attacker who wants to DOS you, um, physical presence ownership transfer might be sufficient because, again, like someone with physical presence can destroy your device. But there are problems with physical presence transfer because, as has been pointed out very helpfully, sometimes we don't have pins to assert that presence signal, and it will look different uh, based on the device's form factor. How will an SSD do ownership transfer? This like will it do differently than a NIC? Can we standardize this? And it also would like if you carry that concept into like all the way into a data center, now the technicians would need to do some possibly non-trivial things to each. Like the machines are getting very very complex and disaggregated, and so requiring technicians to assert one particular pin but not others on each one of the devices that compromise a machine or that comprise a machine. Um, would probably be burdensome, and so like an authenticated uh, cryptographic scheme is attractive in that way, where you just have to plumb the signals. And then, oh
Uh,
yes,
I've got a question. So originally when we came down the ownership transfer path, we were addressing cloud environments and circular economy. And that kind of led us off to the physical presence path, right? Because of all the complexities of having, managing keys and all that stuff. But are we broadening the scope now and saying, well, if you need to do authenticated ownership transfer, this is how you should do it? Or if I'm just confused about where we're going.
yeah. I guess so. I think that authenticated ownership transfer um, it definitely has a place in the supply chain, and so if it gets defined, that's cool. For that reason. Also, I think that there are use cases for authenticated transfer even within a data center. I think that
I would agree.
yeah. So it's worth defining it.
There's there's kind of two types of ownership transfer, and they potentially have different trap models. So one is transfer of ownership where you get to run arbitrary code on the device, or you get to run your own code, or whatever you want. Like think of a BMC or an FPGA or something where you write the code yourself and you run it on that device, or most people download some reference and then build on top of it. That's one form or one type of device. And then there's the other type where you don't get to run arbitrary code on the device. The manufacturer of the device determines what's authentic, and the owner gets to determine which of those authentic versions of code get to run on the device.
Yeah.
So those carry different trap models. I think when you get arbitrary code execution, you can do some of the things like Eric mentioned earlier, like run diagnostic code that can potentially exfiltrate secrets. And, so I think like a trap model maybe through those two different modes and lenses could help distill down the solution, like what we're trying to accomplish with transfer of ownership, whether it's arbitrary code execution, or maybe it needs another name like personal bills or owner authentic firmware versus manufacturer authentic firmware.
Yes, and I think to the point of the supply chain aspect, what I'm seeing is that the actual who is the manufacturer, who gets to just in this world in which the only manufacturer authentic code runs and the owner can set a policy on what's authorized to run. Even in that world, I think the notion of who is the manufacturer can change in the supply chain, right? Maybe the device was manufactured by one party but then sent to another, and now they have control of the device, and from thenceforth they are the manufacturer for the purposes of who gets to run code on it.
Yeah, that's true. That's common.
Jeff, is circular economy just another variation of supply chain?
I think a case. I think yes. I'm willing to be tested on that.
So yeah, I see it a little differently, the manufacturing part versus what happens in circular economy or in the data center once you play with ownership transfer. The way I've been thinking about this is I'm thinking of a model in manufacturing where you have to go through multiple contract manufacturers, right? And each one of them is going to do something to the device that they need to do. And furthermore, they're going to set some, let's call it irreversible state, right? Something like burning a fuse or something on the device that's going to put it in some state as part of that manufacturing stage, right? And then, but in order to set that stage, you need to be the owner, right? Now, once that state is set, even if you're the owner of the device, you can't change it because it was irreversible, right? So those are the things that you would do in the manufacturing state. Once you get to the circular economy or to the data center, then I would expect the ownership is going to allow you to change certain things, but those things are not necessarily irreversible, right? You see what I mean? Like who can put new firmware? What key do I use to authenticate the firmware? Those kinds of things, right? Rather than setting secrets, for example, burning keys, I don't know, something that you do during the manufacturing process that is irreversible. So I would expect that in the manufacturing process, right, when you're going from A to B to C to D, right, and those are all manufacturing steps where you're setting up this, what I call irreversible state, right? In that case, you don't even want to have physical presence access, right? Maybe the last manufacturing guy turns on physical presence so that you can do gain ownership with physical presence, right? But before that, if you're an A, you want to make sure that only B can set that state. And if you're in B, that only C, and so on and so forth. That's the model I had in mind.
Mm-hmm. And it also, like, there's much less of a coordination burden in the supply chain, the manufacturing line, where you know that A is followed by B is followed by C. But once you hit circular economy, I'm going to sell it off. I don't know who's going to take ownership next.
Right, exactly. So then you don't know, right, what state. That's what I'm saying. At that point, the state that you can control through ownership is the same, and it can be changed by the owner, period. Whereas in the manufacturing process, the state only changes, is only going to change one, is irreversible, right? And it can only be changed by this one entity.
It occurs to me that one could argue that, in fact, it is the manufacturing line which is a specialization of the supply chain. If you can solve the supply chain, let me rephrase. The manufacturing line is a specialization of circular economy. If you can solve circular economy in the general sense, then you have solved manufacturing in the specific sense. But there's you don't need to do as much to solve the manufacturing line, because you don't need to do infinite transfers. Things can be irreversible, and you do know the identities of the next parties.
Right, and I would say that it's also important not to have the physical presence enabled during manufacturing, because you know exactly who should have it and nobody else should have that that device, right?
If that is important, that physical presence be disabled because you don't want someone with physical access to be able to take ownership and be able to run their code on your device, I think that requirement would hold for that device for the duration of its lifetime, right? This would be the kind of device which only runs vendor code, for example. Would that be accurate?
Well, what I was thinking, and again, I'm making all of this stuff up in my head, right? I'm just thinking how you could do these kinds of things. But what I was thinking is, in the manufacturing process, I would have physical, in the most generic case, physical presence would be disabled initially, and only the owner that is set up in that device, you have to do ownership transfer before you go from step A to B to C, right? And only the next owner can do stuff. So if somebody intercepts the device and gets it and has physical presence, they can't do anything with it because they're not the owner, right? And then the last step in the manufacturing, let's say the last step was D, right? At that step, if it's possible, then that's when you would enable physical presence, so that for the data center and circular economy and all of that stuff, physical presence is there, which is important. That's one model, right?
Mm-hmm. And I guess I was trying to wonder if, like, the reason why you want physical presence disabled prior to D is because we don't want someone running their own diagnostic code on the device, for example.
It's typically, I would say, if we go with the model that you're setting some irreversible state, right? You're setting up keys, you're burning fuses, you're doing that kind of stuff. You don't want anybody else to be able to do it, but somebody that is authorized as a manufacturer to do it.
Mm-hmm.
Right? And
so the
it's not that
you do that, yes.
Yeah, what I would say is it's not that you cannot get at those resources later, right? When you have physical presence enabled, it's just that those resources can only be set once, so you can't reset them anyway.
Yes, that makes sense. Right. Okay.
I'm kind of trying to think of physical presence sort of as the ultimate super user, right? And that's what you want to disable during manufacturing, is what I hear you saying.
Yes, that's exactly it.
Okay.
There's actually, I have this next slide. Let's see if this is helpful. So I think it's going to touch on that. So I'm trying to characterize like when you might want each flavor. So why do you want authenticated? Useful when having ownership of the device like gives you more powers than you would have had by physical access alone. So that I'm trying to think if that captures what we just talked about with the supply chain. I don't think it does. I have to amend things here.
Yeah, the difference with the model I have in mind, by the way, it's just the model I have in mind. There's other ways of doing stuff, but with this particular model, the difference is the state of the resources that can be affected by ownership transfer is different, right? In the manufacture stage.
Mm-hmm.
And once you get past manufacturing, those resources get kind of locked. So it doesn't matter that you have ownership of the device, you can't change them.
Mm-hmm.
But that's still a setting that the owner could set, the current owner. Right?
They correct at that point in time, yes, to lock them. Yeah.
In a sense, it seems like whatever ownership might be transferable about the device, whatever aspects might be controlled by an owner, is just different once manufacturing is done. Like, okay, ownership meant this before now. You could change these fuses, whatever. And now it means something else entirely. Those fuses are no longer controlled by an owner. Those are immutable. And now this other configuration.
Right. And I would say maybe a way to look at it is to say that in manufacturing, the resources that get changed at the data center or once you have physical presence, you could probably change them in manufacturing, assuming that the device is in a state where those things make sense, right? But that's not the primary use, right? But there's definitely two different stages. Is the early manufacturing stage where things happen in a certain way and ownership guarantees certain things, and then the resources that get accessed later, they're definitely a subset of what you could have access to in manufacturing or change specifically.
Yes.
I'm having trouble wrapping my head around the whole physical presence thing because, I come from the tampering background, right? And so I think, well, physical presence is all of everything. How do you disable physical presence when you have physical presence? It's how in the world can you shut it off because the person has.
If you, yeah, that's true, right? The way I was thinking about this, and again, is my own funny world, right? Is I was saying maybe the physical presence device or pen or whatever doesn't get enabled until the last step in manufacturing.
Mm-hmm.
Right before that, it's not connected or whatever, right?
Yeah, the way I see this is it's during manufacturing, it's not even necessarily ownership transfer. You're just doing manufacturing the device. You have all these things. The manufacturer has much more that it can do with the device during manufacturing, and then it sets some kind of fuse or something, one last step that now puts it into quote unquote production, and now it this concept of ownership applies, and you can assert physical presence and take ownership of the device. But I get what you're saying, Alberto. It's a subset. What you can do, the types of configuration changes you can do using this ownership mechanism is less than what the manufacturer can do.
Right.
And now, given we kind of touched on how hard it is to actually define a standard physical presence ownership transfer mechanism, I'm wondering if there's a way to. I guess I'm wondering if we can do without it. Maybe not do without it, but like I think we need to define flows which don't rely on physical presence.
I agree with that. I think physical presence is an issue.
Yeah, I mean, I've always seen physical presence more than an ownership transfer is ownership erasure, right, so to speak. Meaning, or taking the thing back to the state it came from when it came from manufacturing, right, from the last step in manufacturing.
it's possible that.
It also seems like physical presence ownership transfer should be able to be enabled and disabled in certain situations, even if it might be present, but the current owner has to enable it.
Mhm. And it may be that that physical presence is a feature that the device manufacturer is expected to implement and use, and end users like data center operators are not expected to involve that, to incorporate that into their day-to-day flows. Like it's useful for RMA perhaps.
So I agree that in the data center, you should not be using physical presence. You should be using, you're the owner, so you should use those credentials to do whatever you need to do, right? The problem I think we were trying to address with physical presence is what happens with when a company goes out of business, or
Yes.
let's say that the platforms get repossessed or whatever, and then the owner is not cooperating, but you need to make them useful again.
Yes. In that case, is it reasonable to require those devices to go back to their manufacturer so that the manufacturer can assert physical presence using whatever mechanism they designed to get those devices back to a state where they can be sold?
There may not be a manufacturer anymore.
May have been out of business, yeah.
And that's a pretty heavy burden.
Agreed.
To send it back to the manufacturer?
Yeah.
Yeah, it's a burden on the manufacturer and the people that want to transfer, have the used equipment and want to add it to the circular economy.
Yeah.
Right. I think the requirements where you don't want to send it back to the manufacturer, but you want to put it in the state so that any secrets or anything that was in that device before goes away. Right. So it goes to a state that is very similar to the first time the first owner got the device.
It also, like, as long as the physical presence feature was designed, implemented, and documented somehow, and you don't necessarily go back to the manufacturer who, may be out of business or it's too burdensome to receive those parts, but whoever buys them can assert physical presence. There wouldn't be something that is expected to be done on a day-to-day thing, but in this edge case where we need to recover these parts so they can be resold, maybe that's the way to do it, just as a one-time thing.
I thought, Jeff, that at one time you proposed having sort of a ratchet where the owner, the ownership history or transfer history, call it that, was involved in setting the new state, that you couldn't ever go back to way back to manufacturing state, but you could go forward and wipe it clean, but it still recorded that you had done that.
I believe what I think you're referring to is like this notion that the device has some kind of ownership epoch that gets randomized on change.
Yeah, right. That was
and
it.
I think that would still work here. Like, okay, the device, oh, hey, someone is asserting physical presence on me. Let me rotate my epoch and make it obvious that something happened.
Yeah, that was it.
Yeah, I think what you want is you want to prevent the insider case where you're inside the data center but you're not an authorized owner, and you assert physical presence, you change the state of the device, and then you do something nefarious to it, and then you put it back in operation and the data center never finds out. We definitely want to make sure that's not the case, right? If the device sort of changes ID or something in some way, then it's detectable, right?
Yeah.
And it seems like that if it was tied to either an authenticated transfer or a physical presence transfer, if you had that capability, you could at least detect it.
Yes.
Yep.
You could even enable it during manufacturing if you wanted to, depending on how much you can keep around,
Yeah. And it's, all of these schemes, like we talked about this like a ways back, but like I think all of these schemes where we're rotating persistent keys within devices and like rotating ownership epochs are challenging when all you have to work with are fuses. much more easy to do this in a circular economy friendly way when you have some flash at your disposal.
Yeah, that's true. So maybe that's the requirement. If you want a more secure record or whatever, you got to have flash.
Yes, but then even even leaving the ownership epochs out of it, it seems like if you want some healthy margin of I can do ownership transfer X times, you might need to target that to devices with flash. I'm not sure how to do that when, say, you got a CPU with internal fuses. And certainly that can support all the ownership transfer flows where you're in the supply chain and you're doing these one-way functions. But once you hit a world where you might, go through several iterations of ownership transfer, I don't know if we can have the device burn fuses on every one of those.
Yeah, I mean, the problem is going to be there's always going to be, if you put a, say, I'm going to have 10 sets of fuses, then somebody's going to want to do 11
Exactly.
ownership transfers. So, yeah.
Yeah,
So that,
or you can denial of service it too,
Yeah.
run it through 11.
that seems to suggest that, let's say there's cases where the owner, let's say this is a device, say like a CPU, where some parts of the code are only expected to be run by the manufacturer, or it's supposed to be authored by the manufacturer, and so we can enforce signature on that, which need not be rotated. But then the owner is expected to modify some other parts of that firmware, like say the BIOS. In that case, if the owner wishes to enforce some policy on what code is allowed to run inside that CPU, I think that policy needs to be enforced outside of the CPU. Now, volatile ownership authorization involves in the instantiations that we explored here previously, it was involved like a hitless update, and that's fine because you can latch the public key into RAM. But if you're worried about what code can run at all, like I don't even want anyone's code but mine running in the first place, even after cold boot, then I think that policy needs to be enforced outside of the SoC. Say by, I don't know, either an EROUT or a BMC or a PA route perhaps. Interested in others' thoughts.
So how does this relate to ownership transfer again, Jeff?
The reason I'm exploring this is like, and I know this probably kind of isn't in the slides, but the thought occurred to me. So defining some generic ownership transfer mechanism for, like, say, authenticated ownership transfer, and then putting it on every device that we ingest might not be the direction to go, just because every device that we ingest, they don't all have internal flash. They can't all support a rotatable owner policy or owner keys.
I think, Jeff, that it comes down to the storage medium is really a threat model question, and that's going to vary not just based off of what kind of deployment, but what kind of device as well, because each device has different kinds of assets in the system at large. And so for that question of, say, why can't I store the ownership material in external flash versus internal flash versus fuse, it comes down to, is that anti-replay attack, or rather that replay attack, in scope for ownership of that device? For some devices it may be, for some devices it may not be.
That's a good point. Yeah, that needs to be described. Okay. Yep. To do. Let's see.
So maybe one thing that would be helpful in this case is if we could define the resources that are controlled when you're the owner, right? And that may tell you, like for example, in some devices, if those resources don't exist in a particular device, then they don't have to support ownership, right? Or if we say this particular resource has to be available in every single device and it has to be settable by the owner, then every device has to support ownership.
Yeah, and that might not be
Right.
a good direction. Yeah, and that's actually like part of what I was coming here trying to learn. I know you probably won't be able to talk about all of this like in this meeting, but like I I have a perspective as a data center operator and kind of looking at certain devices, but I'm interested in like other people's on this call's like perspective on what we want to use ownership transfer for, what assets there are that we want to control, flows in the supply chain that are outside of the purview of the actual data center. So possibly like an email thread would be useful. If anyone has thoughts, feel free to shoot them.
I think I'd like to go back to like the threat model and scope the threats for supply chain that we're trying to address.
Okay.
Because that could help us like form the solution. So if we're worried, for example, if we're worried about secret exfiltration, maybe the device shouldn't carry secrets or meaningful secrets at that point.
That would be nice. I think any device which does dice will have a secret that we want to keep safe, right?
Yeah.
So yeah, I see that. Yeah, defining that threat model will be useful.
Yeah, maybe I get that dice secret doesn't get regenerated until the device is safe or it's underneath ownership.
As in the device has no secret until it's been fully manufactured.
Yeah.
That could. I mean, I think that might pose challenges to like these cases where the device is manufactured by one entity and then given to another to integrate into a board. It would be nice to have some kind of identity that says, "Hey, it was definitely manufactured, you know, by whoever like initially made it." But you can insert additional entry read accounts.
But if the threat is like arbitrary code execution on a device, if it's in a case where it's manufacturer assigned, is that a threat in that model, or is it a threat in the model where anybody can run, the transfer of ownership model where you can run arbitrary code on the device? I guess it could be a threat in both, but maybe there's some way it's mitigated in one rather than the other.
Yeah, the thread that I was more concerned with in the manufacturing stage is definitely not one about secrets, right? It was more about the ability to set resources to certain states, and those resources could be a key that is used later, for example, to validate code that is going to be executing in this device, right? But that key has to be set by stage B of the manufacturing process, not stage A. So when I send the device from stage A to stage B, I set ownership so that only stage B can set that key and nobody else. Otherwise, I'm going to have, if a bunch of these devices get stolen, somebody can come and set that, and now they look like original devices, like the good devices, but they have this code that is running, for example, that is not that was not authorized. That's the kind of threat that I was thinking about.
I see. But is that still like a manufacturing incomplete stage, or you think they can finish out the manufacturing but keep it in a bad state?
No.
Yeah, I was concerned about, and I don't know now I'm going out of of what I really know, right? Would it be possible to, for example, instead of going A to B to C, to go A to B prime to C?
Yeah, I would argue that that path should be attestable.
Yeah. Yeah, but the thing is, yeah, it probably depends on how you define manufacture the device from the very beginning. But if you have the stage, which each one of the stages puts attestation information for the next one and so on, then you need to have this restricted stuff.
Yeah. Yeah, I guess, to properly address, to allow the scenario and then to secure it, probably need to put the scenarios down, so we can build like a comprehensive threat model for it, how it should be addressed.
Mm-hmm.
Yep.
And then the other thing is what transfer of ownership accomplishes. I think that was the other thing Jeff mentioned, the rationale for it, why it's important.
Right. So the rationale being there is a policy on the device that I can control and that exerts my will over the device.
Yeah.
Yeah, it depends on, as earlier, like, well, what are the assets that I might want to control? Let's see. Do I have any more interesting stuff? Oh, yes. This is just a diagram that shows a model where there's one larger operator, but several embedded owners, logical owners that don't wish to necessarily trust each other. So this is a case where one could hypothetically have tight control of devices as they transfer. This actually, this is a model, I think, for the supply chain. Just make these linear instead of all smushed. But going from one entity which can control certain keys to another entity which can control different keys and then different resources, like A, B, C, D, and then you're done. And tight controls of the hardware as it traverses through each state. So this configuration exists in the supply chain. It could also exist in certain data center scenarios.
So in this model, the device is the thing in the middle, right? The white.
Oh, sorry. This is that's a good question. This is kind of hastily put together. This is like the choke point, the place where ownership transfer is. In this model, the devices go here before they transition to the next state, next owner, just so you don't have owners sending things to each other.
Oh, okay.
But in the supply chain case, you would go straight from one to the next, and wouldn't have to traverse a central distribution hub.
But yeah, but the important thing is each one of those states in the colors happens only one of those states at a specific time.
Exactly.
Right?
Yeah. I trust this green dude has control of me, and then the red, and yeah.
Yeah, makes sense.
What did I write here? How to make authenticator transfer tractable. So when transferring from A to B, you could send the device to B and then have B go reach back and say, hey, A, can you unlock this device for me? That can be workable. I guess what the context of this slide is kind of saying, like, if we were to give an authenticator ownership transfer API or define one, owners might have several different ways of interacting with it depending on their predilections and abilities. So yeah, you could reach back and ask A to unlock it for you after you receive it. A could transfer it straight to B. So this is like the supply chain model. I know it's going to B, so I'm going to transfer it to B before I ship it to B. Or the circular economy model where A says, I don't know who's going to have this, I'm going to unlock it and then ship it to whomever. When you're doing the first of these, you're going to have some kind of service that is available to all the potential next owners, which might be everyone in the world, depending on if you're doing circular economy. So you might not like to do that. And you have to have confidence that the device actually left your control before you allow anyone else to request it. If you have loose controls there, someone could say, hey, I've got the device, can you please transfer it to me? And you might do so even though you didn't actually intend to send the device anywhere, which would be bad. When you're doing either of these two things, when you're transferring the device or unlocking it before you ship it to B, you have to have tight controls to make sure that you don't actually ship a device without doing that first. Otherwise, it will arrive at the destination and they will have no way to take ownership. But if you can do that, if you do have tight controls of your hardware and can ensure that you don't ship a device on before unlocking it or transferring it, then I think authenticated ownership transfer is tractable, and we do not end up in that world of shared databases and painful coordination problems. It's a burden on the owner. So this would be, I guess, a question. For people in the supply chain, I think this is tractable, just because like the endpoints A, B, C, and D are well defined, I imagine. I'm curious about any other people's thoughts. If people who would like to use ownership transfer flows are well equipped to have these tight controls of the hardware. I know that for some devices, Google is. For others devices, it would be hard right now.
But you're suggesting that all three of those transfer options would be viable in the same. In other words, you're not saying we need to pick one. You're saying all three of those should be viable, which I think makes sense if that's the case.
Yeah, that's basically. I think the same device API could be used in any three of these ways.
Okay. And I think people need to have the different options, because some people are just not ever going to want to, support option number one there.
Sure. Yeah, it's not attractive to me either.
But in some instances, for example, really expensive devices, it might be attractive in some cases. I don't know.
Yeah, it could be.
And low, maybe like devices where they're very expensive, but they don't make that many of them.
Mm-hmm.
Otherwise,
yeah, when it's all manual one-off, then yeah, do B, send an email with a file, or do the first one.
So how does physical presence fit into this three different cases? Doesn't seem to be covered by them.
It doesn't. This is all focused on getting authenticated ownership transfer to work, because, like I said, there are cases where it is important to get that property. Like
right, but we want to make it tractable also when there is physical presence, change of ownership, right?
Yeah. So when,
or at least detectable, right?
Yeah, and can we if authenticated ownership transfer is made tractable in the general case for a device? Let's say that all the owners do B or C, like they have the ability to control the device, make sure they don't ship it unless it's been unlocked or transferred to the right owner. If they're in that world, then in what cases do we need physical ownership transfer? I think it is exclusively that edge case where the owner has gone out of business and cannot transfer any of their devices away. Are there any other cases where we want physical presence to function?
I don't think it's necessary because I think essentially your item 3 there is essentially enabling physical ownership transfer.
That is true.
And then, but you're right, we still have the case where the owner A, the current owner A is gone out of business and they have all these devices and they aren't going to be interested in doing any of these things.
Mm-hmm.
And then what do you do?
So in that sense, or in that case, then would it make sense to say the device manufacturer may or is encouraged to implement a physical presence ownership transfer mechanism that can be used to rescue devices? The device owner could decide to disable it. Say, hey, I'm the owner, and I actually don't want physical presence to be able to transfer ownership away from me, and I, the owner, accept the responsibility that I might have burned all my parts in case I go out of business. It can be up to the owner to decide whether they want that insurance that the devices will not go into a scrap heap, or whether they would rather have the security of not being subject to a physical attacker. I think it depends on the assets.
Yeah, I think it makes sense to make that part, to give the owner the ability to disable physical presence ownership transfer. And I think it also should be optional for the manufacturer to support it, but it could be recommended.
Yes, and in that line of thinking, I like, what do people think here? Like, should we as a group try and define a mechanism for physical presence ownership transfer, or should we say devices are varied and different, and the vendors are best positioned to design such a mechanism?
Yeah, it seems to me like you should leave it, you should basically propose a general structure of how that might work, but leave it up to manufacturers to do what they want to do. Another thing I have heard about too is that sometimes manufacturers don't even want to have the ability to provide a mechanism to physically or to reset the device back to the factory state, because then that, if they give a security breach and that information gets out and an attacker uses it, there's liability there for them.
Mm-hmm.
Potentially. So, I mean, that's where the lawyers would come in, right?
Yeah, you want to be able to make guarantees. Okay, so
Jeff, just two things. I agree that big picture, we can't enforce kind of a very detailed physical presence. It'll vary widely depending on how the system's designed. One thing I'm kind of struggling with is I don't think we should call it unlock. I think we want to go to like a transfer of ownership state where effectively the only thing you can do next is basically claim ownership. So it's not like we're leaving the device completely open. We're effectively putting it into a state where the only thing it can do next is to transfer to ownership. Is what I'm thinking. Is that?
Oh, sorry, go on.
Is that clear?
Yeah, it sounds attractive. I have a question about. So let's say, for example, it's a CPU involved. Would it ever be the case that in order to actually assert ownership, I actually need to get it to boot and do many things before I can get to the point where I can actually talk to the device and program whatever owner bundle I might want? If there's ever any kind of circular dependency there, that might be problematic.
Agreed. But the model, I think, from a TPM, and others on this are much more knowledgeable than me, is that it's like first in. So the first person or first that configures it, I own it. Perfect. So then I think the question is could we use that and have a state where we explicitly relinquish ownership in which it can be claimed again, and use that and maybe some logging to kind of understand what path this has went through.
Yeah, well, so we have that that owner epoch, so we will know when an owner
Right.
change happened.
Correct.
We could also say, and I think we do want like the device's like dice identity to be tweaked based on that owner epoch.
Agreed.
If we can swing it, it could also be nice to actually embed within the device as like identity. Oh, by the way, I'm not owned. So then.
So one comment about the dev identity is there is some binding between the device identity and the manufacturer.
Yeah,
That's
we
of course
can
a
actually
device.
modify that. Yeah, the device ID key needs to remain immutable. Agreed.
Right. So maybe if you use the LDEV ID and IDEV ID concepts, maybe that works.
Right.
Yeah. Something not the device ID or whatever was joined by the manufacturer.
Right.
That's a good question. On the unlock code, is it per device or for all the devices?
I think it would be on a per device level, but it depends on the asset, because in some cases, like the really important asset that the owner cares about is in one place on the machine. Everything else can hypothetically be more or less cryptographically stateless. And then I don't need to actually do ownership transfer on all of the devices, just the ones that have the assets I care about.
Okay. And how do you identify a device to a key? In this case, let's say I've got thousands or tens of thousands of devices. That means I need thousands or tens of thousands of unlock keys, right? So how do you match them, right?
Yeah, that's a good point. I'm imagining if it like to carry this to its conclusion, I'm imagining we'd need some kind of redfish bindings so that a BMC could, enumerate, here's all the devices I have that that can change owners, and here's some redfish actions for doing so. I agree there can be a scalability problem when you have tens of thousands of devices all in there. So we should maybe try and not be in that world where we're doing 10,000 ownership transfers for a machine.
But if you have the situation where each device has a unique device identity, which is more and more common these days, can't you use that? I mean, you obviously can use that, and and the manufacturer, and if you're going to do anything with attestation, you already are going to have all that infrastructure in place.
You're right. Yes, yeah. Something will need to be challenging all these devices with their identities. I think we can. I think that ownership transfer can be orthogonal to like attestation and identity. Just in cases where the device supports both, then they should work together.
Okay. Yeah, that's a good point. And also, since a lot of smaller companies may never want to implement attestation, it may not make sense.
Right.
Or at least it'll be quite a ways down the road before they would do so.
Mm-hmm. Okay, so sounds like we authenticated ownership transfer is worth speccing out. We need threat models and a description of assets.
And then it sounds like, I think we've had a couple people that said for option 3, we need a real tight definition around, or at least some definition around what unlock means.
Yes, yeah. Elaborate on that. Okay. This is good stuff. I think that's all this. Oh yeah, questions. That's fine. We already answered those. So, okay. I think that's the hour or half hour. I think we have what we need to move forward for now.
Thanks, Jeff, for getting this together.
Yeah. Thank you, everybody.
Bye-bye.